This is the lecture for section 5.2, verifying trigonometry identities. So there are going to be 4 videos total. You can thinking about as like more the basic one, a little bit advanced, and then more complex problems. During those 4 videos, I'm going to try my best to limit it into about 5 to 6 minutes each, and show you how to, or different techniques on how to verify identities. Okay, so this is the first video. We're going to talking about the more straightforward basic ones. So at the beginning, you do need to make sure you have all your identities either memorized well, or for the more complex ones, you're going to have it handy next to you, because you are going to referral to those identities very, very often throughout throughout this entire section. So I'm going to do examples first, because there's not really too much definitions or any conceptual information is going to go through. So I'm going to show you how to do problems. So the first one is we want to verify identities. That means we do need to show the statement, the mathematical statement we have is valid. So the statement we have is secant of theta times sine of theta plus cosine of theta equals to 1 plus tangent of theta. Okay, so I'm just write down the title for the example. So normally when we try to verifying identities, we're going to start, or the question is given you in an equation form. So what we have is a left-hand side, and then we also have a right-hand side. And they are separated using the equal sign. So on the left of the equal sign is the left-hand side, to the right of the equal sign is the right-hand side. We normally don't spell out, so we just say LHS stand for left-hand side, RHS stand for the right-hand side. When we try to verify the identities, we want to see, okay, if I'm going to working on one side, by simplifying one side of expression, can I got to the other side? In general speaking, we're going to start from the complex side. So for this example, the left-hand side is more complex. That means we have more room to simplify it. We can multiply it. We can rewrite the secant in terms of 1 over cosine and multiplying, simplifying versus 1 plus tangent. Yes, I can do a little bit, but not too much. It's more, comparing to the left-hand side, is more simple. So it's much easier to work, or we always want to start from the complex side. Okay, so now I'm going to actually working on this example. So when we try to start a problem, we normally say, okay, which side are we going to start from? So for this one, I'm going to start from the complex side. So left side equals, so that means I do not need to repeat my entire problem. Left side will equal to, I'm going to multiply it using the FOIL, or not FOIL, just simple distributed property. Okay, just do step by step. I see the secant theta times sine theta, so I'm going to rewrite secants in terms of 1 over cosine. Also write sine theta in terms of sine theta over 1, because next step we're going to doing fraction multiplication. So once we rewrite it in terms of 1 over cosine for the secant, what we see on the second part is 1 over cosine theta times cosine theta over 1, which will give us 1. And then to the left side, I will have sine theta over cosine theta, where sine theta and cosine theta can rewrite it in terms of tangent theta. So after simplifying the left-hand side, I end up with tangent theta plus 1, which is equal to the right-hand side. It's not exactly the same, but just the order is slightly different, but its additions 2 plus 3 is the same as 3 plus 2. And we are done. And we're done for the class, or for this example. So pretty much means when we're doing the verifying the identity problems, you have the starting point. For example, the left-hand side. You know what the final answer is going to look like, 1 plus tangent theta, the right-hand side. And what you need to do is fill in the middle step. How can I get from point A to point B? What is happening in the middle? So that is pretty much all you're going to do for the verifying the identity one. Okay. So for this one, you can try to do verifying the identity for cotangent theta plus 1 equals to cosecant theta times cosine theta plus sine of theta. Okay, so you have the starting point, you have the end point, and then now you're going to connecting the dot. How can I get from point A to point B? What is the necessary steps? Okay, so you can try that one. Now for the second example, still the same instruction, verifying identity. What we have is cotangent square x times tangent square x plus 1 equals to cosecant square x. Okay, so we follow the same rule. We're going to start from the complex side. For this case, the left-hand side is more complex than the right-hand side. It's more longer, it's more complex. So we're going to start from the left-hand side. So I'm still going to multiply everything. So I have the cotangent square x multiplied by tangent square x plus cotangent square x plus times 1, which is just cotangent square x. Now I'm going to simplify them. Cotangent square x I know is 1 over tangent square x. So what I have on the 1 over tangent square x times tangent square x over 1, I will end up with a 1. So after simplifying the left-hand side, I end up with 1 plus cotangent square x. Now from the identities, we have 1 plus cotangent square x will equal to cosecant square x, or theta. So this one will equals to the right-hand side. Okay, so I'm just going to write one more step, which is equal to the right-hand side. For this example, you can follow up by trying tangent square x times 1 plus cotangent square x equals to 1 over 1 minus sine square x.